Hi there. In this video, we're going to cover how to find all the possible rational zeros of a polynomial. And so we have the rational zeros theorem that if you have a polynomial p of x of any degree, of n degree, with integer coefficients, then every rational zero of p is of the form lowercase p over q. So this little fraction where p and q are integers and p, so the numerator of this, is a factor of the constant term, the coefficients of the very last term. So that will be all the factors of a naught are p, and q is all the factors of the leading coefficient, a sub n. So let's try an example. Let p of x be x cubed minus 3x minus 2, and let's use the rational zeros theorem to find all possible zeros. And just to give you an idea, so I'm going to go on a little bit of a tangent here. If you wanted to factor the quadratic, say p of x equals x squared minus 2x minus 15, what would you do? So back to just factoring and thinking about quadratics, you will be looking for the numbers that multiply to negative 15, right? So that's exactly, you're using the rational zeros theorem without really even knowing it. So you will look at the factors of 15, negative 15 really, and see, and then you're trying to see, and the quadratics are a little bit easier because then you're trying to see if they add up to negative 2, but really you're looking at factors of negative 15, which are 5 and 3, like negative 5 and 3, or 5 and negative 3, and then 15 and negative 1, or negative 15 and 1. So you're essentially doing this, and notice that the coefficient of the x squared here is 1, so we don't really end up dividing by anything, like the q here is just 1. So you don't end up seeing it too much, but you're essentially using the rational zeros theorem. So back to our example here. So the possible rational zeros, so this is important, they have to be rational, will be all the factors of the constant term, so the factors of negative 2. So think of what are all the factors of negative 2, and then divided by the factors of 1. So all the possible zeros are going to be then plus or minus 1, plus or minus 2. Those are the factors of negative 2, and the factors of 1 are just plus or minus 1. So the possible zeros are plus or minus 1 and plus or minus 2. So let's see if any of these work. So let's look at 2. Is 2 a factor? So is 2 a 0 of p of x? And again, how do we check if something is a 0? We do synthetic division. So I'm going to say if 2 is a 0 of p of x, then I should get a remainder of 0. So I'm going to have my coefficient. The coefficient of x cubed is 1. The coefficient, notice that there's no x squared. So we're going to have 0. So we're going to have the 0 for x squared, then negative 3 for x, and negative 2 for the constant term. So I'm looking over here at all my coefficients. And there's no x squared. And we draw our line for synthetic division and bring down the very first coefficient of 1. And now I do my multiplication. 1 times 2 is 2. And remember, with synthetic division, we add. So I get 0 plus 2 is 2. 2 times 2 is 4. And we add. Negative 3 plus 4 is 1. 1 times 2 is positive 2. Negative 2 plus 2 is 0. So that's a yay. So 2 is a 0 of p of x. Right? So that means that if I do p of 2, I'm going to get 0. What about negative 2? So is negative 2 a 0? So let's see. Negative 2, put it in. 1, 0, negative 3. This is our p of x, the coefficients. And same thing, we're going to do our line. Bring down the 1. 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2, and then multiply it again. Negative 2 times negative 2 is positive 4. Negative 3 plus 4 is 1, and then 1 times negative 2 is negative 2. Now my remainder is not 0. Negative 2 minus 2 is negative 4. So this is, nope. So negative 2 is not a 0. Negative 2 is not a 0. And so on. So you can see, you could also try to see if our possible zeros were plus or minus 1 or plus or minus 2. We check plus or minus 2. We could do synthetic division to check plus or minus 1 as well. But let's try a different example. So let's try, let p of x equals 2x to the fourth minus 9x cubed plus 9x squared plus x minus 3. So notice that there are no degrees missing. So this is good. So we don't need placeholders like we did for the previous one. So let's go ahead and list all the possible rational zeros. Remember, a rational number is essentially any whole number, any integer, and anything that can be expressed as a fraction. So possible zeros are going to be possible rational zeros are the factors of negative 3 divided by the factors of 2. So the factors of negative 3 are going to be plus or minus 1 and plus or minus 3. That's the nice thing about 3. You don't want to have like a 12 or an 8 here because those have a lot of factors. Factors of 2, that's also a prime number, so plus or minus 1, plus or minus 2. So I usually do it by looking at, starting with the first one and dividing them one by one. So plus or minus 1 divided by plus or minus 1 is plus or minus 1. And plus or minus 1 divided by plus or minus 2 is plus or minus 1/2. Plus or minus 3 now divided by plus or minus 1 gives us plus or minus 3. And then plus or minus 3 divided by plus or minus 2 gives us plus or minus 3/2. So these are all the possible zeros. So notice that for this polynomial, we have, counting the plus or minus as 2, right? So we have 2, 4, 6, 8 possible zeros. Yikes. That's a lot to check. So you will start checking all of them. So if you want to see which ones are zeros, I'm going to start with the 1. So 1, and I write my polynomial, right, the coefficients. So it starts with the degree of 4, and then 3, 2, 1, 0. So there are no holes there. I don't need a placeholder. So 2, negative 9, 9, 1, and negative 3. And this is why synthetic division is nice, because with long division, this would be very long and tedious. With synthetic division, it shortens our work. But synthetic division only works for checking if things are zeros, meaning linear terms on the bottom. So bring down the first coefficient, so 2. 2 times 1 is 2, so I line it up there. And remember, with synthetic division, you always add. So negative 9 plus 2 is negative 7, and multiply it by 1, again negative 7, again add. So 9 minus 7 is positive 2. 2 times 1 is 2, and then add them. So 2 plus 1 is 3, and now 3 times 1 is 3, and negative 3 plus 3 is 0. Yay! So we found a 0. So 1 is a 0. What about negative 1? So I do it again for, is negative 1 is 0. So let's see. 2, negative 9, 9, 1, negative 3. And as you start doing this, we start getting a little bit faster. So bring down the 2. 2 times negative 1 is negative 2. That gives me negative 11. That's not looking promising. Negative 11 times negative 1 is positive 11. 11 plus 9 is 20. So it's going to be very hard to get back to 3, right? We need negative 3 plus 3 to be 0. So I need to get a 3 at the end. Getting a 20 here is not looking promising. So 20 times negative 1 is negative 20. Plus 1, negative 19. and then negative 19 times a negative 1 is positive 19. So when I add 19 and negative 3, I get negative 16. So nope, negative 1 is not a 0 of p of x. And so then you can go down the line. So what are our next ones? Plus or minus 1/2. So then we will do, let's do 1/2. So I'll do the same thing. So I'm going to have, so this one with the fraction is a little bit interesting and it might be intimidating, but don't let it intimidate you. So my coefficients are the same, 2, negative 9, 9, 1, and negative 3. Right, don't let it intimidate you. This just means we need to practice our fractions. 2, bring the 2 down. So 2 times 1/2, hey, that's not so bad. 2 times 1/2 is 1. Add it, negative 9 plus 1 is negative 8. Negative 8 times 1/2, so what's 1/2 of negative 8? Is 4, right? So not so bad. 9 plus 4 is 13. Uh-oh. So I spoke too soon. 13 times 1/2 is 13 halves. Now I have to do a little bit of work. So common denominator because I'm adding. So I'm doing 13 halves plus 1. So it's 13 halves plus 2 halves, which gives us 15 halves. So 15 halves. And then multiply by 1/2, sorry. 15 halves times 1/2 is 15 fours. And it doesn't matter, it's not 0. Right, so this, you can do it. So 15 fours minus 3. So common denominator is 4. So it's really 15 fours minus, what, 12 fours? So that gives you 15 minus 12 is 3. So 3 fours. But it's not 0, so 1/2 is not a 0 of p of x. So notice that it starts off a little bit intimidating, but it's really not. So negative 1/2 now. Let's try it. So my coefficients don't change. Still, we're just checking into the same polynomial. We're trying to see if which ones are zeros. So bring 2 down. 2 times negative 1/2 is negative 1. Negative 9 minus 1 is negative 10. Negative 10 times negative 1/2. So what's half of 10 is 5. Negative times a negative is positive. And let's see, 9 plus 5 is 14. 14 times a negative 1/2. So what's half of 14 is 7. And it's negative. So 1 minus 7 is negative 6. And negative 6 times a negative 1/2. So negative times a negative is positive. And half of 6 is 3. So check that out. Negative 3 plus 3 is 0. So yay. Negative 1/2 is a 0. So negative 1/2 is a 0 of p of x. So how do you know how far do you need to go? So let's see. So there are some theorems coming. So this is a 4th degree polynomial. So we're going to have at most 4 zeros. Now the rational zeros are different. So we can have complex zeros and real zeros. So far we have 2 rational zeros. And if you keep going with plus or minus 3 and plus or minus 3 halves, you will see, so positive 3 is a 0. And so this so far will have 3 real zeros. It might have all 4 zeros be real numbers, but sometimes we may have a complex 0. So there's another rule, the rule of the Card's rule of signs, that tells you that you're going to have the number of zeros. It depends on the sign change. So for example, this one, looking at p of x, so how many sign changes do we see? So it goes from positive, this is positive, to negative. So there's one sign change. Then it goes from negative to positive. So there's another sign change. And then positive to positive, so that didn't change. But then here, there's another sign change. So this tells me that this polynomial, p of x, will have at most 3 positive zeros. So it's going to have 3 positive zeros or an even number less than this, than 3. So how many do we have so far? We have positive 1, and I told you that positive 3 is a 0. And same thing for, so then for the negatives, the negative zeros is you plug in p of negative x. So you do, for the negative zeros, we find p of negative x, and then look at the sign change in these ones. So when you put in a negative x, right, any negative to an even power becomes positive, so that's going to stay the same. And negative to an odd power stays negative. So negative x cubed is negative x times that negative becomes positive. So plus 9x cubed, that's going to stay positive because when you plug in negative x in here, negative x times negative x is positive x. Now here, I'm plugging in negative x, right? So it's going to be negative x and then minus 3. So how many sign changes does this have? There are no sign changes until here. There's only one sign change. So that means that p of x will have at most one negative 0, which we already found it. It was negative 1/2. So we have a negative 0, so that's it. So in a way, that helps us say, okay, well, I don't need to check, since negative 1/2 is a 0, I really don't need to check negative 1, I don't really need to check negative 3, and I don't need to check negative 3/2. So based on the Cart rule of signs, we already know that of the ones that we have here, we already did 1 and minus 1, we did 1/2 and negative 1/2, right? We checked 4 of them. We have 4 more to check, but because we already have 1 negative, that means I really only need to check 3 and negative 3. 3 and 3/2, sorry, because we already have the negative. And we know based on the rule of signs that we have at most 3 positive zeros, and I've found 2. 1, and I told you that 3 was 1. So we really just need to check if 3/2 is a 0. If it's not, that means that the other zeros are complex numbers. Okay, so using the Cart rule of signs in this one, in the first one we did, notice the sign change. So we have only one sign change. So that means we're going to have at most one positive 0, which we found one, right? 2 was a positive 0. We didn't check 1. And now I know that I don't need to check it because it's going to have at most one positive 0, and I already found it. For the negative zeros, I will need to find p of negative x. So p of negative x will be, right, negative x cubed will be negative x cubed and plus 3x, because if you put in a negative x in here, you're going to have negative times a negative is positive, minus 2. So there are how many sign changes? So you have 1, 2. So you have 2 sign changes. So you're going to have at most 2 negative zeros. And so we checked negative 2, and negative 2 was not a 0. So likely negative 1 might be a 0. So you would want to check negative 1, right? Notice that we only have one positive 0. We already found it, so we don't need to check positive 1. But there are 2 negative zeros, and we've only found 1. So we might want to check negative 1 and see if that's a 0. If it's not, that means that we'd likely have a complex 0. And that's in the next section, section 3.5.